Alright guys, we're gonna get the sleeve that I Loctited on this shaft. We're gonna get it off. Let's do it. Gotta be getting close. It's gotta be getting close. It is not coming. Oh, that's coming. It's off. Here. Turned it. Got it off. It's pretty smoky. But that's that green Loctite, man. Stuff is freaking crazy strong. Right? Strong as an ox. And here's your piece. I turned this one purple. Last time I did not turn it purple. Sorry. Hope the camera's catching that. Can you see how purple that is? Anyways, I don't need that piece anymore. I had my slide hammer, piece of pipe at the ready. Alright, I'm going to just scrape this off with a razor blade, let it cool, and on to the next one. Alright guys, let me give you a setup glimpse of what I'm doing. I've got the tailstock quill hanging off the side of the Bridgeport. I've got the head at 45 degrees to the side. Let me back up here. There's the front of the table, and the head is off at a 45 degree angle, approximately. I didn't even bother to, you know, look, but I've got the grinding vise. I think this is a 3-inch vise. It's set up because it's all ground on 4 corners there. I set it up to capture this shaft because now that the bronze nut fits in there, I'm going to put 4 bolts around it and put a retainer plate. So as you can see, I've got this thing all zeroed round and round and round. And my setup is, I got lucky, these are 3/8 holes. I think they're 10mm holes. So I got a 3/8 bolt, 3/8 stud with a 3/8 T-nut. I have some 3/8 T-nuts as well as 1/2-inch T-nuts. And as I said, I got a 1/2-inch T-nut there, strap clamp, and I'm holding this side down on this particular T-slot with some spacer blocks. Pretty simple. It's locating in the V. It's not quite touching the bottom, but the V keeps it centered and vertical. I got the keyway just visually at 90 degrees. It's not a big deal. Now that I got it centered, I might put a point in it and just visually see if the point is in the middle and adjust it. But it's going to be a 4-bolt plate to hold in the bronze nut. Where's the bronze nut? Let's get the bronze nut. Bronze nut, baby. Do 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 do. And this nut is tapered 1/2 thousandth, believe it or not, and it does not matter which way it goes in. That out to the way. It's a little tight. Yeah, okay, it fits better. Ooh. this shaft cooled down. It was hot when I had it in the lathe. But that's a good fit. I don't want to drop it in because then I won't get it out right now. Yeah, see, it doesn't fit quite so nice that way. But I've had it in and out before, and I've gotten it out with my pinky, so it was just warmer in the lathe. But I'm going to leave it. So the thing is, once it's in there flush, I'll put a washer with 4 bolts, like a flange, to capture it. So that's that. And as far as my setup, that's as complicated as it is. It's just my vise sideways. And I've got a sideways vise, but this works out for now. So, all right, we'll check back with you. You know, I find it funny that after the job is done, I find the clamp for the steady rest, and I forgot I had one, so I made one out of aluminum, just a piece of aluminum stock that I drilled and tapped a 1/2 inch hole in the middle. And then after I'm done, I find the real deal block that's supposed to be used to attach the Hendey steady rest. It's so funny. It was sitting behind, it was under that like black toolbox thingy behind the Colchester 17 here. Oh well, it's just an aluminum, it's just a piece of aluminum with 1 hole drilled in it. I'm sure I can use it for something else. But I forgot I had this. I guess I'm getting to the age I forget things. Oh well. You might find this kind of cool if you've got a Hendey tool and gauge maker lathe. This travel stop for the bed is actually off of a South Bend, I think it's a 10-inch South Bend. I don't know. I don't know if it's not the heavy South Bend, but the light South Bend. I'm not sure. It just fits on there like it's made to. You know. And one thing I did is I milled a little step inside, or on the bottom bracket rather. You can really see, it's in the shadow, but I think I milled, I don't know, a 1/16 off that. But other than that, she fits great. So, little tip for you guys if you got the same lathe. All right, well, I just wanted to share my my steady rest clamp brain freeze right there. So, all right, bring it back. All right, guys, got the 4 holes drilled and threaded for 1032. You know, I want to show you guys. This is the kind of tap I use for a blind hole. This is called a spiral flute tap, not to be confused with a spiral point tap. And this is a Kennametal. So good tap. Always use a good tap. I start them with the chuck and finish with a little hand tap wrench, a Starrett in this case. I like these polished ones. I think this is a Series 91, or I forget what the real small ones are. Something I like to use, see this stuff, Relton A9 aluminum cutting fluid? I mean, it's oil, tapping oil. They make regular, Relton makes regular rapid tap or something. But this stuff smells so nice. It's green colored. The oil's green. And I happened to get a can of this, and it smells so much nicer, and I just use it for everything. I don't use the old stuff anymore. The yellow bottle, or the yellow can rather. And I always put a drop of the black Molly in there. This is actually Castrol Molly D, which works really nice too. Anyhow, thought I'd share that little bit with you. So I ran the file across it, deburred it. I took an old Craftsman screwdriver handle and I melted it in there, melted the file tang in there. And this is my favorite file. It's dull now because this file is probably going on 25 years old. But now it's a burr file. You know, it's not as sharp as it was, but it works. But anyhow. Alright, now I'm going to make a little flange washer to hold that in. Yeah, that's all I'm gonna... I'll probably use another piece of this cut off of this 1.5" bar to make it out of. And it'll only be 1/8 thick or 3/16 thick, something like that. The heads of the Allen screws, you know, I could put washers on them. Maybe that's all I need. I don't know, we'll see. We'll figure it out. Alright, bring it back. Alright guys, I thought about it and I kind of realized I didn't show you the piece I made for the to hold in the Acme nut. So let me do that now because I want to be complete in how I record this stuff for you guys and for myself for future seeing what the heck I did here. All right, so there's the bronze nut put in there, and that's as out of the box from Roton.com. It's right at 7/8 of an inch diameter, and it's 1 inch long, and it's flush with the surface, okay, which is not going to clamp it. If you put a flat plate on there, that's not going to clamp it because it's flush. It's not putting it in compression, and it could just spin. There's nothing holding it from rotating. So what I did here is I left a protruding surface. As I said, the nut is 7/8 outside diameter. This is about 15 or 20 thousandths less than 7/8, that raised up surface. Okay? And I surface ground this after I was done. I left it a little proud on the size and flat ground it on the surface grinder. So that will bear only on the bronze, right? That'll push. I mean, you get the idea. I hope it's focusing, and when it goes on there, you know, it'll push exclusively to hold that bronze piece in there. You know what I mean? And you got my four screws to hold it in. Yeah, there's the old tailstock, and the old. You can see the new one is pretty much twice as long as the old one, as far as the tailstock quill itself, and the Acme nut, which I have it over on the other bench. But anyhow, that's what I did. And I surface ground this side too. I know it's hard to come in focus with the camera, but this is a cool little dealio. As I said, I cut a 1/4 inch keyway, so I always have clearance for the 3/16 key. That's just clearance. Oh, and you know, the shaft is 1.5 inches. I think I turned this thing down 20 or 30 thousandths less, so this never gets hung up in the bore. So, all right, I'll bring you more. All right, sitting down over here. Got the tailstock quill, and you can see it has the nut inside, maybe, and I've got this nut plate, this retainer plate that I just made. I didn't film it, whatever. It's got those 4 Allen head cap screws that are 10/32, and you see I notched the plate for the keyway. It's a 3/16 keyway in the shaft and a 1/4 inch, clearance slot, so I can get this out of the tailstock out the front. Otherwise, the plate would hang up on the key, So, yeah, man, this is a really big achievement, and it's all the way through. Right? I don't have the socket Loctited in, but whoop. All right, come on. I'm not a video photographer, a videographer, but it's all the way through, and it doesn't rub. Again, it's a 9/16 drill hole through the entire thing, and a 1/2 inch Acme that I bought from Roton.com. So, yeah, super happy with that. Boing. All right, well, I'm pretty excited because it's been a long time coming to get this thing situated to where it's at. I'm gonna go eat some lunch. Yeah, and this is the old, like I said, that's the old way. There's a Dutchman in there, or a Scotch key, or whatever you call it. And I just didn't want to do that. It's sort of a one and done approach. I've seen them fail where the bronze nut splits in half. That's why I did that plate. That plate's a more positive way to retain it, But I don't know if I can get back enough. I mean, this is the old and this is the new, right? It's double as long. All right, I'm done being impressed with myself for now. I will continue being impressed with myself in a little bit later. All right, I'm gonna have some lunch. Until then, Doozer shop. All right, guys, I'm gonna document this before I screw it up, right? So one of the questions that was on my mind, this is the 1/2 inch Acme 2-start thread, and I need to put a flange on it for the thrust bearing, and I also need to attach a crank handle at the end of the tailstock. So this measures like 2 thou under 1/2 inch at the outside diameter, the major diameter, let's say. The minor diameter is 0.369, 370, something like that. Just a smidge under 3/8. But anyways, I thought about turning it down to 369 and then cutting a 3/8 coarse thread onto it and then making some adaptation. What I'm thinking of doing to make a really strong connection, I mean, if I turn this down to say 3/8 and I, take off some of the thread and I left with a solid core, or, not 3/8 but 0.369 or whatever the minor diameter of this thread happens to be, you're losing a little bit of strength from removing the actual threads, and this is going to be in torsion, right? You're going to put torque into this, and it's going to be in compression from the thrust bearing. So I had a plan. What I want to do is this. Notice I got a hose clamp on here. Oops, I'm doing the shoot my feet, right? Don't do that. I turned up, this is just under an inch, like 15/16, doesn't matter. It's going to be processed after anyways. So I got a 1/2 inch hole in there. And I counterbored a 3/4 hole in this side. So it's 1/2 inch all the way through, if you can see that. Whoop, whoop. So my idea is to do this. So the counterbored hole will be at the butt end, at the bitter end, right? And can you guess what I'm going to do right there? We've got the oxygen and acetylene. I want to braze this in. So I want to braze this sleeve. The thrust bearing will be, you know, where the, I'll cut a step in it with the lathe. The thrust bearing will be here, and, you know, probably turn it down to 3/4 or something and put the crank handle on it. And the bearing for the tailstock, the butt end of the tailstock. So that's my plan. I'm probably gonna tin this with bronze, and I'll tin this with bronze, and hopefully I can slide them together and just do a solid fillet. Just fill that whole thing in. I got my bronze brazing rod, and I put the hose clamp on there because I want to slip it in the hole of this rim. And I think there's a thing in the, there it is. It's a pulley down there. So then I can set it on there and fill it up with braze after I tin both ends. I wanted to tin them initially with braze because just to make sure it sticks and I get no freaking bubbles or any weird anomaly stuff. So that's what I'm going to do. I'm not going to film it, but I'll bring it back when it's all done. Alright guys, let me bring it in. So that's the end of this Acme rod. And you can see it's got a nice bit of braze in the threads and all the way around. And the same for this socket. Oops. Got a good bit of braze wetted in that socket all around. Oops. So what I'm going to do is put you here on the camera pod. Come on, camera pod. Can you see that? Yeah, I think you can. And we're going to try to braze this on. Let's light the torch and figure out what we're going to do here. Bang! Of course, why wouldn't you? Okay. All right. So, oh, where's my brazing rod? Hold on. Very important. All right, got the brazing rod. We preheat this. Grab it the right way. Let me give it a little more fuel and fire. Slightly carburizing to protect, you know, the world. So it heats straight down on this guy. Preheat it. Oh yeah, it's glowing. Preheat it. Drop this on. There you go. Yeah, you can see that. little bit higher. Yeah, that should be all right. I think I want a little bit more heat. That's getting pretty red. Put the heat down from the top now. Come on, get in there, Rod. Flowing nicely. I don't want to get it too hot because then it'll lose all my braze rod down the threads maybe. Oops, go too close. Turn it 180. Oh, I can see a molten puddle. That's good. I do have shaded glasses, but I don't think I need them for this. It's not super bright. All right, that's filling up. Kind of angling the flame at a 45-degree angle here. Oh yeah, getting a nice fillet. Building a nice fillet. It's hard to tell if it's flux or bronze, but I believe it's bronze. I'm going to be facing this off a little bit at the end here at the lathe, but not too much. Oh yeah. They say better to be looking at the weld that you need than looking for the weld that ain't there, or the braze in this case. Man, I'm liking that. We just crown it by heating directly in the center at the top. Bake out some of the flux anomalies if any do exist. It's pretty straight up and down. Oh yeah. It's a nice crown of bronze. it's starting to cherry the entire top. I don't want to go too crazy, but I know if it's hot, it's all adhered and penetrated. Just a dull red color is what we want. I'm not going to monkey with that. I'm not going to monkey with that at all. I'm going to show you guys, and I'm not going to touch it. Right? I mean, that's pretty darn toasty. So I think that's going to be a super strong connection. I got it in the rim here. So the connection, of course, is at the top here, and it's free thread, you know, all the way in the middle. This is 3.5 inches long, by the way. But I'm quite happy with that. Turn the lights back on. Clean up my mess. I am very religious about shutting the torches off. People would say, religious, Doozer? What do you mean you're religious about it? Well, if you don't shut them off and you forget, your gas is going to leak out. So religious or religion comes from the Latin words re ligare, and re ligare literally translates to repeat. To repeat. So religion means to repeat. And I repeat the action of making sure that these are shut off. Anyhow, it's kind of interesting. Is it etymology of words? Where they came from, where words came from. Because it really helps you understand the meaning of the words today as they're used. Anyways. All right, so that's going to cool. I'm going to let that cool for like at least 20 minutes, a half hour. And then I'm going to figure out what size I'm going to make for the bearing, the through hole, and the hand wheel. So anyways, hope you enjoyed that. That's my idea anyways, to make a solid connection to this feed screw without undercutting it, and I just want the maximum strength possible. Turning it down to 3/8 would probably be fine, but you know, if you put a pin in a 3/8 shaft, you reduce the cross section and you make it weaker. If you thread it, I mean, you're taking it down this is barely 3/8. It would end up being 0.369. Like I said, it would accept a 3/8 16 thread, which is a 3/8 coarse thread. But I don't know. I just want this as strong as possible, and if this ever has to get changed out for some reason, I can just melt the braze out. So, anyways, we'll bring you back with more good stuff.